So, hello everyone, and welcome to our talk today, Life Hacking Cloud Architectures. I don't want to bore you with a lot of who we are, but just a few words. Thorsten and I are consultants at Novatec Consulting Company. And since our main work lies around cloud architectures, we are, of course, very interested in security topics. Our employer, Novatec, is a consulting company mainly based in Germany. We have also a branch here in Spain, Granada. And our main focus is about modern software engineering and technical enablement. Just a small disclaimer before we start. You can imagine how much we could achieve today or show in our talk. However, unfortunately, some things came in between that made it much more difficult to achieve them. However, we prepared something for today and we hope you enjoy it. So, we all know like every single detail in our life today is connected to the internet. A lot of critical infrastructures, smart devices, almost everything that we say or we do can be on the internet. And on the other side, the attacks and threats are evolving very fast, and it's very important to protect our systems and data against that. Otherwise, a lot of bad scenarios can happen. And mentioning that, let's have a look on some examples on things that you would not like to hear or read about your companies someday. Let's start with the EasyJet example, what happened in 2020, where the credit card information about almost more than 2,000 customers have been exposed, which made them non-compliant with the GDPR. And you can imagine how bad that could be and how much money as a fine you should pay by then. It can go even worse. What happened with LinkedIn 2 years ago? Usually, the funny fact is that when you design APIs, you maybe focus on a lot of design details like, do I use boot or post method? Do I use /user or /users and such details? And you forget to secure your APIs. And exploiting those LinkedIn APIs, the PII of almost all LinkedIn users could be exposed and sold out in the dark web. Another bad example, what happened with Twitch. Maybe the name is well known, especially for parents who have kids interested in virtual gaming. So here the entire source code, including some intellectual properties, have been exfiltrated. The vulnerability was using a system configuration change that allowed unauthorized access. And the sad thing is that they were very prepared in a professional way, using some red teaming tools and so on, but still they got attacked. And last but not least, maybe the worst, what happened with GitHub last year when a malware has been integrated into a dependency, which is used in very well-known projects such as Docker, Kubernetes, Crypto, and many others. And what it does, it sent the entire environmental variables to the attacker server. Well, we mentioned the word attack several times. So what happens starting from the point where the attacker decides on their victim till the point where they achieve their goals can be summarized mainly in 4 main phases. Starting with the reconnaissance phase, where they try to gather as much information as possible about their targets. They try to identify them, to collect some valuable information, to scan for vulnerabilities, and then comes the attack. They are in. They got an entry to the network, they gain access, they try to escalate their privilege and do whatever they want. So extract data, encrypt them, infect the network, whatever their goal is. Then comes the expansion phase, where they try to get into each and every system connected to that network. So they try to hide in multiple systems. and can regain access when they want. And finally, after achieving their goal, they end up with the obfuscation phase, where they clean up everything, every single evidence of their presence. They cover the origin of their attacks. They make it harder to discover their identities, how much information have been compromised, everything. And in order not to fall in those traps, it's better to be prepared. So do threat modeling, penetration tests, try to bring the application architecture security into the scene. Well, we prepared something for you today. It's not totally made up. It's based on real-world use cases that we see and face in our daily jobs. We have a consulting company in the financial sector that protects you against cryptocurrency heists. It's called Never Victim Consult. They claim that they cannot be attacked or hacked. And what they did is that they did a great step. They migrated to the cloud. They talked about it in a blog post. And that's great, by the way. But that's how they caught our attention. So we read their blog posts, and we had a look on some details, some tools, and even better, we were able to find the DevOps team who's responsible for that step. And now, let's meet them. Let's play a little bit with their cloud architecture. And Thorsten, stage is yours.
Okay. Blood pressure is rising. Okay, so this is the first time we are doing this talk. So please forgive me, I need to look some things up here. How to meet a company. Well, we saw that they have a domain, and the first thing that we can do is to check what this domain is made of. Therefore, we are using a DNS enumeration tool on Never Victim Consult XYZ, and that gives us plenty of information. For example, we see they're using Google domains. That means they're using Google Cloud DNS, probably they're using Google Cloud Platform, but unfortunately that also means that we are not able to do a zone transfer. A zone transfer, if you're a bit familiar with DNS, that would bring us a lot of more information here. So we cannot gain more information from that, but we can do another thing. We can use a DNS reconnaissance tool in order to do a brute force attack on Never Victim Consult XYZ, and we have speeded the things a bit up and using 25 threads here. And the trick here is that we use a dictionary which is based on a word list. And we are going to use a word list with the 5,000 top subdomains that are used by the top 100 million most trafficked domains. So DNS reconnaissance is now asking that DNS domain, that the domain of the domain name service of that particular domain is there, that domain from the dictionary. And we've found out that Never Victim Consult maybe is using Outlook, Office 365, they have a staging domain, and they have a test mail server. So the test mail server, that's interesting, right? It gives us the information that maybe they have a staging, right? So let's dive a bit deeper. Let's do a brute force on that subdomain, test Never Victim Consult, and let's see what we else find there. That will also take some time. You can read it, right? Yeah. And there are things that we well known. There's a Git subdomain, there's something social, no idea what that is, but there's Nexus. We know Nexus. There's probably a dev machine, and there's a Jenkins. Well, Jenkins is great to know. Right? So let's try to find out more about that Jenkins. We are going to use another tool, which is Metasploit. Hands up, who knows Metasploit? Oh, okay, good. So Metasploit is a framework, a collection of many, many tools and scripts for penetration testing or analysis. And we are going to use something from the auxiliary module, a scanner for HTTP-based applications, and we're looking for Jenkins. So what does Metasploit provide us for Jenkins? Enumeration tool. Well, that's fine. So we're going to use that module and need to configure it. To configure it, we need to set the remote hosts, which is Jenkins. That we already found out that. Test.never victim consult xyz, don't make a typo. And yep, so let's see. Can we exploit that one? And we see no response. That's a problem. Let's try another one. Let's use another port. Let's use the Jenkins default port and exploit again. And there's the information. We see Jenkins in a pretty much modern version. That's bad news for us. There are things restricted, and that's making it a bit hard to get access. But we can ask Metasploit to help us here. Search, exploit, Jenkins. There are plenty of exploits here. Let's use Jenkins version 2. And unfortunately, there's nothing in that particular version, at least. So the talk won't stop here. I have another idea. There are more modules, right? Let's see what else we have here. Jenkins, and there is a login module. So let's try to log into Jenkins. Let's prepare the Jenkins test. And that needs more options. So we are happy with one success. So set stop on access. Let's do that for yes, which is true, not yes. And what else can you see here to prepare? That's something I need to tell you here. The most modern Jenkins installations don't use that security check anymore. They use, maybe you know that, from some failed logins of your, they use the Spring security check instead. Or if you have if your Jenkins administrator is a more sophisticated one, you maybe have something like ping access security check here. Okay, so what do we need to log in? Yes, you're right, a username and a password. So passwords, that's easy, because we do have word lists. There is a well-known word list, which is the RockU word list, which provides 32 million leaked passwords. And I have that word list here. Let's use that. Demo talk. And let's make a Jenkins brute working folder. And, well, 32 million will take some time. So I prepared a subset right in the middle of that big list with the most complex, not the most complex, but with the sophisticated ones. Yeah? So we're going to use this particular area. And now we may have some passwords. What else do we need? Usernames. And usernames, what comes in your mind to get the usernames here? As Mirna showed, we met the DevOps team, right? Yeah, you want to tell it, right? Yeah. And we can generate some usernames from very well-known patterns. So I prepared that. User. So that are the names that we read on the website. So we are going to use a Python script, because everything runs with a Python script. User. No autocomplete here. Python 3 user list. let's move. Oh well. Let's move output text. I will show it list later on to. I need the autocomplete here. Also move user list output to Jenkins brute passwords dot users dot text. Okay, so now we got a bit prepared. So set user file. We are going to configure it Metasploit again to users users.text. Set pass file to that was passwords, right? Password list. Okay, so well, let's try to exploit. Fail to validate. Why not? My hands are a bit shaken here. There it is. So you can recognize it tries to use different patterns of usernames, which is script generated. And it's using the URL and trying to log in, and it is going to stop if it has a succeeded login. Maybe you can imagine 32 million will take some time, and you can do a distributed access here. So you would instantiate many more VMs or many more Metasploit instances with many more threads in order to do a brute force login attack. And it should succeed soon. There it is. So, well, we have a working Jenkins login. That's great. Then let's try to use it, I'd say. Because seeing is believing, I prepared a VM here. Well, we're going to use a private window. So, which is Jenkins test, never victim consult, XYZ, AD. A well-known Jenkins login appears, and we need to copy that one with shaking hands is quite hard. Copy it into that VM here. Oh, come on. Paste. So it is already here. And then we need the password. Anybody in here who is felt a bit catch with that username pattern? Saw that at your customer maybe? Okay, that was the wrong one. So I'm pasting that one here and try to log in. And there it is. A running Jenkins instance with some jobs, and now it is totally clear what social means. Social seems to be an API, and with a CI job, with a deploy job, with the infrastructure job. So what's the interesting thing about the infrastructure job? So maybe it's using Terraform, and in order to use Terraform to do anything against a cloud API, you need what? You need credentials. And, well, credentials is interesting for us, right? So Jenkins, if you're a bit familiar with Jenkins, oh, well, there are jobs ongoing here, so I'm probably not alone on this instance. So credentials can be used with a credentials plugin. Well, let's see what credentials we have here and how's the timing. Timing is perfect. There are some credentials here. There is a Kubernetes config, there are some client IDs, Redis is in use, it seems, and there is something GCP test. The service account, can you read that? For infrastructure pipeline for stage test. That seems promising, right? Well, unfortunately, we cannot read it here. But I show you a little trick. Jenkins is quite friendly. It offers us, if we are authenticated, it offers us the script console. And I try to get it back from my mind, which is an interesting command here is Hudson util secret decrypt. Let me check if it's the correct run. Yes, it seems. Yeah. Okay, so where do we get the encrypted secret? That's funny because this is the encrypted secret, and we can inspect here and copy it. Exactly. And then, well, let's try to paste it here. And if I did no typo, there is something. Any idea what that is? Wow. Come on. That's a base 64 encoded string, I would say. At least it looks a bit base 64-ish. So the problem is that it's, yeah, right. Well, then let's try to decode it. Yeah? Let's make a folder which is called Cloud Access. Maybe that's interesting here. And then use encrypted JSON. I will switch back to the other terminal soon. Paste clipboard, because I expected it hard to read. So that's why I pasted it here. Okay, so can you read that here better? This one? Okay. Then let's see. Cloud access. We do have the encrypted one, and we're going to decrypt it. We're going to do a cat encrypted and send it to base 64 ---- decode and write it to gcp.json. If you're a bit familiar with some cloud APIs, this is going to be a service account. Service account is the word for Google Cloud. Service principal is it on Azure, so you name it. So, and then let's try to log into gcloud with the auth model. Activate, oh well, no, autocomplete again. Activate service account, and it's key file. Is it key file? Well, I didn't prepare that. Key file, I think, is GCP. gcloud init -- console only. And well, I'm going to use any session here. And now we see we do have two accounts here. A default account, which is pretty much not secured, and a Jenkins account. So we are going to use that Jenkins account. Well, it's 2, not 2L. And yep, right. No zone here. So now I have access with gcloud from a leaked service account, and now let's see what I can see. what are we interested in? Maybe some container clusters, right? Which is gcloud containers container clusters list. Okay, let's try to container clusters get credentials. It is region, totally different for Azure CLI, of course. You need to memorize all of them. West 3. Well, I'm going to copy that. So prod is interesting, right? I would say prod is interesting. The region, the 3. Oh, very good, thank you. Kubeconfig, also interesting. Let's use test also just for the sake of fun, and now let's discover that cluster. We're going to use Octant. Somebody knows Octant? One hand. Okay. Then you're going to learn Octant right now. Octant helps us to explore a Kubernetes cluster a bit more visually. Yeah, you can see that one. So let's see what is there. We do have some namespaces. We have namespace CRM, so there are some customer data probably. There's a key cloak where you can now do some things with. There's a namespace called toolchain. And there's our friend Jenkins. But there's something else. There is an application. So application is always interesting. A backend, I would say. A backend with some credentials, of course. And what can we do here? Let's start a terminal. Let's see, who am I? I'm root. Let's see what is the environment. That's a OpenJDK 17, and there is a very, very strong password. Well, there's a database actually from a backend, which is probably listening to that social domain. Let's see how bad is the timing. Timing is good. The database can wait a bit. So let's see what else is on that cloud. gcloud. What do you else would expect from a cloud architecture to be there? Anything besides containers? Any ideas? No ideas. Okay, I have one. I would say, do you know the storage accounts? Storage accounts are also interesting, right? There's that is called storage bucket on gcloud, and well, maybe there are some buckets. There's not only one. Okay, that's much to read. Let's use grep. Grab the idea. So there is an infrastructure of code, an infrastructure as code bucket, which for sure contains all secrets which are going to be created via infrastructure as code. But that one can also wait. There is a database backup, which is quite interesting for us, right? I would say we are going to exfiltrate that one. Exfiltrate. And since we seem to be authenticated via gcloud, we can use gcloud storage to download the whole bucket, which is, you need to know the notation here, but the thing that an attacker really has is time. So you could really well prepare here. So And what do we want to download here? Everything. And it is downloading. It downloaded almost 300 megabytes of data. We do have a write-ahead log. We do have a complete database backup, an incremental backup, it seems. So let's remember, we found out they're using Jenkins. We got access to the Jenkins. We leaked a Google Cloud Service account. Now we have access to prod here. Well, we don't know if we have access to prod. It's actually test us, so let's see if we can use prod again. Well, you see my name in here. That's the thing that we made up, right? Let's see what namespaces we have here. There's also that app, and there's also a backend pod. And let's see who we are on prod. We are again root. Probably it's the same container, the same container image. And what you now could do is we could place a backdoor here. We could place an exploit which would open us a Metapreter session in order to remain access. So and that's the thing we're going to stop today. We have root access to a container. The thing about containers is if it's going to be stopped, our access will be lost. So we need to make sure to retain the access. We could also compromise some pipelines here, because what we definitely have is we can assume that that Jenkins instance is also getting backed up. And with that backups, we definitely could place another exploit in order to get access each time we want to have. Okay, so questions so far? I saw some big eyes here. So maybe you recognize that it's not really that hard. Well, Mirna, do you want to add something here?
Yeah, so when it works.
I think the battery is low. You need to come near to closer.
I'll just use that. Yeah, just a small recap. So we saw a red team trying to attack the cloud architecture. Maybe Thorsten was lucky to find that Jenkins key to access Jenkins. However, there are many different ways. So there are much more sophisticated ways to access Jenkins too. What we didn't manage to show today is having a blue team who is tracking everything, getting everything, and trying to react directly. And what would have helped them in such cases is having observability tools in place, things like Tetragon, Falco, SIM, the security information and event management tools, in order to track and get the events, the logs, everything in real time, and enforce some runtime rules to react to that directly. Things like defining some rate limits to prevent some specific types of attack, to make brute forcing attacks much more difficult. Following the least privilege principles, defining the least privilege or the zero privilege at first, and then adding them when needed. So don't give the high privilege directly and make the users be able to do whatever they want. And last but not least, applying the service-to-service security principles. So maybe you've been in the talk this morning of Adib Saikali, where he mentioned or talked a lot of patterns and ways to achieve that, using, for example, the platform identities, the mutual TLS, and the OpenID Connect patterns, and much more. So, observability is not a security silver bullet, however, it's a paramount. And with that, we want to thank you so much for your listening today. And do you have any questions?
Don't be shy. There's a question.
Yeah, hello. Thanks for a great presentation. How would then the persistence would look like if you want to continue accessing the same container again and again? Like you said, it would take more time to explain it, but I'm just a bit curious. Thank you.
What we would do is we exploited data, and we would simulate that I come again and try to get access again. But next time, Mirna placed some observability tools and some policies which will notify her when I do a brute force on the DNS or on the service account, and then you could send me to a honeypot, for example, or you could just well, it's totally not okay to have a root shell. It's 5 lines of code in the YAML to prevent root shells. But what we used here is the default OpenJDK image. It provides root access. So that are things that we would prevent the next time. And tools like Falco, for example, makes that very easy. So we would go through how to configure them, how to create observability with some managed tools, with some open source tools, and then use something like Tetragon, which is eBPF based, in order to prevent my intruder or send me to the honeypot. That is the idea about that. That's what we usually do. Building architectures will include such technologies in order to make it a bit more hard to compromise an architecture. Further questions?
Yes, I have one. Yes, I have one. What would be your alternative way to get inside, like to get some access to credentials? If you don't get access to the Jenkins and the rest of the stuff is just packed in the cloud, and you don't have an on-premise server?
Well, the Jenkins is in the cloud. That was hosted in a Kubernetes cluster.
Yes, but when you didn't get access to it.
Okay. What I want to mention here is you could get access to Jenkins in other ways. There are 2 more options. You could do password cracking, which is not that hard, but it takes more time. And another one is using a Jenkins exploit for vulnerabilities, but it also takes more configuration, which I was not able to fulfill for today. What I used here is exploiting the authentication, but you can also authenticate with an exploit. So another idea is, which can be, maybe you recognize that I'm using Kali Linux here, so you could do very, very easy social phishing logins. That is another way, which makes it easy to get access. So that's why I mentioned they're using Office 365. Faking an Office login is quite easy. There are pre-installed tools on Kali, which I could also use in that talk. And then click on that link, and now I have the client ID and the client credential flow, probably, and then get access to the social web API. Another idea would be scanning that social DNS endpoint. And we would recognize this is a Spring-based application with an API, and running on OpenJDK 17 is quite good, but it also has some exploits there. We would recognize that that particular container is using a Linux version which also has some exploits available. So there are many entry points. Jenkins is just, we choose Jenkins because all of you know Jenkins most probably. And what Jenkins is
just the first step.
Use search exploit Jenkins and you will recognize there's much more way to do. Yeah.
Perfect, thank you.
Right.
So it seems like every other attack we see in the wild somehow exploits Jenkins. Are there ways to harden a Jenkins instance?
Yeah.
Or are we better off just not using it?
There are definitely ways. You could, well, you saw that I updated that login URL from the SCG to the Spring security check, for example, using ping access or some other access tools, or just don't use the Jenkins user database. Use single sign-on with Keycloak or whatever. There are many ways to secure Jenkins. Use password policies, for example. That are low-hanging fruits to secure Jenkins. Another idea would be don't make it public access. But well, that comes with some costs. So.
And what about assuming that an attacker gets access to the Jenkins instance? Can we, for example, disable that script tool?
Well, I recognize that I forgot to mention it. I used a login and recognized I do have admin permissions, right? Jenkins, in its default installation, is an admin party, right? So everybody has access to that script endpoint. So you could maintain that access and don't let every user use it. But if I'm going to use an exploit on Jenkins, I do have access to the scripting engine as well. So maybe don't use the secrets plugin, the credentials plugin, but using some integration with HashiCorp Vault, for example, or Azure Key Vault or whatever. Don't store your secrets inside a Jenkins, for example. So it's totally okay and fine to use Jenkins. And with that modern version, it's not so easy to compromise it, but it's definitely possible. It is more like an architectural thing as a whole, not only about Jenkins.
All right, thank you.
Is there like a tool to automatically scan your environment, and then this command line tool you used where that it shows your exploits? Is there something like that to scan your environment and scan all your dependencies, for example, and then get notifications on that?
Yes, there are some. Do you want to answer? Do you want to answer that or no? Okay.
Go ahead.
Well, the thing is, some of them are open source. What you are looking for is Cloud Security Posture Management, CSPM. And there are no very well-known open source tools. What I know what is quite good is Sysdig, the vendor of Falco. Yeah, right. Falco is well-known, and they have a CSPM suite.
Sysdigit, I think.
Huh?
The Sysdigit or the Sysdig.
Sysdig is the company, but well, they have a suite which exactly does that. Aqua Security is another one. In conjunction with Snyk, for example, you can reach exactly that what I write here, more observability on that. I think the CSPM is the best way to start over to get a view of all your architectures. But the interesting thing is, such a CSPM tool has, if you don't pay very much attention to configure it, it itself is a very good way to compromise your architecture. There are well-known exploits for such tools. Yeah. There's another question.
Yeah, so let's imagine that we have the same setup on premises, and then that they have some whitelisting on each of these services. Let's say the Jenkins have some whitelisting, and only the users that are with those IP addresses can access those machines. Is that possible? Is there some possibility to penetrate through that virtual private network and get access to those services as well?
Yeah, absolutely. So the idea is, what do you want to compromise? Do you want to compromise a Linux VM, which is inside that network? Do you want to compromise the F5 load balancer? There are well-known exploits for load balancers. So you just need to get access into the network. For the sake of easiness of this talk, I choose a public access, which most of our customers in kind of way have. But if you're in an on-premise area with allow listing, then you just need to find the proper access point, and that can be a jump host, for example. SSH into a jump host, I think many of us know that, and just imagine combine it with social engineering and social phishing, then there you go.
Thank you.
Seems that was the last question. Thank you very much.
Thank you.